So this is the MyDaq. When you open it, there's the MyDaq, the breadboard, and then it should come with the paper. It's like an envelope with papers, the manuals and stuff. You have these 3 cables and this piece. Here we have the pieces, which are here, and the terminal connector is, I put it in this bag. Essentially, you don't need the audio cables, so you can just put this aside. There are 2 links that you have to go to, and this is where you find the serial number, but I will tell you personally. The serial number is located right here. It says SN, serial number. This is the first website, and this is how you download it. Basically, you have it on all the last test settings, except this, 32-bit is fine. English or whatever you prefer, and just click download. Downloading the package manager. After you follow the steps, you just make an account, and it'll do all of this. You just agree. There's lab view, and basically everything that you need is already pre-selected. You click next. This is the software bundle. Always agree. If you want to read it, read it. Just click next until it finishes, and maybe we will finish now. Now we have all of this here for the MyDaq. If you are looking to calculate voltage, you plug the red cable right here. Otherwise, if you want to calculate the current, you plug it in here. The black one always goes to the black spot, and then this one, really, it depends. Just plug it in. Really make it snug. This is kind of tricky. This is an up close shot of how it looks. These are looking up, and but you gotta press it hard until it kind of clicks. Make sure it's really tight, don't be afraid. And that's it. This is where you would connect all the cables and stuff. Now we plug one end of the USB cable, and the actual USB cable goes to your computer. This shows up as soon as you plug it in. Now go to the bottom and click on Launch Instruments and Apps for this device. This should pop up, and now you have all of this that you will use throughout the course. With this, you can access the digital multimeter, for example, the DC level. A very important feature is the NI launcher, which should download to your computer. So NI launcher, which will be this, and here is the NI registration wizard that the papers here talk about. Just follow the instructions, and that's where you register everything, and then it should work now. So now we'll show you how it works. Now once you input your information, this would happen. So you click Get Register. I mean, it knows that you're connected to this one, for example, and then yeah, use web browser. Just register. Just keep clicking yes until it stops asking you for more stuff. Register a product. So you put the serial number. Now that I put the serial number, this shows up. Registration is in progress. So now we need to wait. Now we've waited a little while. We reload this and we can see. Let's see, it's still loading. We can active software, right? The activation process is right here. We already got our serial number since we already did this process. It already knows. Now we can actually activate it. I have created a simple circuit, which is just positive, goes around a resistor and comes back negative. Positive starts from 0, AO 0, to the yellow to the positive line that is connected the whole way here horizontally, and the negative is also all the way up to here, connected horizontally below this breadboard. So we start at yellow, goes to the green, goes to the resistor, goes back to the blue, and goes through the negative to the orange, back to ground. A ground would be negative. And this is exactly what is going on here. Now if we want to calculate, for example, the current that goes through this resistor, this is what we would do. First, let's say we have 1 cuff voltage in here in the DC level output, which you can find over here, multimeter DC level. You put 1, you start it up, it's running. You start up this, which is already running for me. Remember to put it in the current, click run, and set this to the current. This is voltage, this is current, set it to the current. And now all we have to do, this does depend on which one goes first. So we're gonna put the positive side red and the negative side black. So we put it right here like so, right there on each end, and we can see a positive 2 milliamps, and it might be a little volatile depending on the accuracy of this thing, but if you take it off, it's 0. And if you put it backwards, like so, this is extremely hard to do with one hand. The important thing to point out is that you cannot do this. A resistor cannot go just through its own line. You short the circuit here. This makes no sense. You gotta put it on at least the next one, just a different one, the next one, or even in the next section. This right here symbolizes a break. So you can definitely do this, switch from one side to another side. You can't just do it on the same side, the same line. You'll short the circuit, or it will be unnecessary if you do it with something like a regular jump wire. If you want to change it from one to another, you unscrew it a little bit, you change it, let's say, back to this one where we wanted it, and push it a little bit, and we just righty tighty, lefty loosey, and it's tight. Now we can work on it. That's how you do it. It's very simple. This comes with the breadboard and the MyDaq and everything else. Most of the information you will be asked shows over here. Obviously you cannot just read from this because the graph is not very accurate. You have to look at this. There's times you're gonna look at this, and there's times you're gonna look at this. So just letting you know what is it you're looking for when looking at these graphs. Also, when you want to access the main panel, you will look at it from here and touch this button, and it'll appear once again. If you don't know how to go back to this, you don't have to unplug and plug back again the MyDaq. You go to instruments and it'll appear back again. Also, we're gonna be using at the very end the board analyzer. Yeah, this. So basically, now I'm going to show you exactly an example of how you would use this in an assignment. So now I'm going to show you how to use the board analyzer. Oh, sorry. Basically, you're going to be given the resistor, the resistance, the capacitor, all the values for that, the start frequency and the stop frequency. If we go back over here, let's also this. If we go back over here, you can see start frequency is right here. It's 10 in this example, and then 20K for stop frequency, and peak amplitude will stay at 2. And all we have to do is make this small circuit following this small diagram. So we have 2 grounds, a capacitor, the VO, which is the voltage, this would be the in, and a resistor, and this is in the middle of the resistor and the capacitor. So as we can see here, so it's this resistor, capacitor, and the VO. I mean, we could also get a different. With this, my recommendation is just try different things. It's not that hard. You just gotta play with it a little bit. We have your regular ground connected to the other grounds here through this. You have the VO right here in the middle, like we said, the VO in the middle, and the V in right here next to this ground, which goes to 0 plus. Now we just run it after we have all the values input. So when we run it, we can see perhaps a sort of similar graph to last time. It did change a little bit, but not entirely. The values are given here perfectly, and this is what you have to input for the answers. Once you do all of this, these are the values that you're looking for right here in the X and Y axis. Use these two that go together. This is further down the class, but this is an op amp which basically is this little triangle here. So it goes this way. There's a little circle that you might be able to see in the camera. Yep. That's how you identify which is 1 and which is 2. So it's 1, 2, 3, 4, 5, 6, 7. Right, this would be 8 in theory, but yeah. So this is 2, this is 3, this is 4, this is 6, this is 7. And that is how you look at it. You might be wondering, where's 8 and 5? Well, yes, they're here. So no more questions. Thank you. Now we're gonna go ahead and assume that this is VCC. Not assume, but we're gonna assume that VCC is 15. VCC would be this one, and this would be VEE. We're giving 15, which is exactly what is shown right here. And we're gonna then assume that the V in and VO are 2 volts. Now, when you go here in the function generator, you see that you have the amps. Here's where you put 2. It's the same function that we use here, but we don't use this because you overwrite the system. We only use this that has 2 in 1. So we say 2, and then we say, let's say 100 as depicted here. We're gonna have 100, and we're gonna run it. We're also gonna run this. This is just the measures. This is the scale, which one is fine, and this is A10. Now this is where it gets complicated because A10 is right here. It's a new concept where we're looking at. This is A1, and this is 0. 0 plus will go, according to this, to, let's see, V plus is going to number 3. We can see it right here. This is V in. That would be, and that would be number 3 right here. 1, 2, 3, and this is that one, which goes to a 0. A negative and 1 negative go to the negative, which is connected through here to a ground. Perfect. And that is how we get this. Now we have, once you run it, we have this. You just zoom out a little bit and you will start getting a better shape. Now these numbers are going to be given. I'm just showing you where to plug them in. Anyways, yep, that's basically it. And then you can, when you have 2 of these 2 op amps, you can select this and then enable it and make another whole circuit in the other side. But for now, we're just gonna leave it at 1 because you get the basics. You just have to do everything again, but for this side. Now, this resistor, for example, is going from 2 to 6, as we can see. So we go 2, resistor, 6. This is 2, resistor, then 6. After the 6, we can see there's a VO. And this is where VO comes in, over here at A10. And then this A11 plus is the one that we named, which was over here in 3, which is this one. And this right here means ground. Ground is connected right here. So you don't really need to connect it to number 3 per se. Here I can move A1, which is also connected, even though we don't have another op amp. For example, this problem. So this is ground. You have it grounded with the other ones, which will be the negative spots over here in A1. That's basically how you set up this. You just follow the instructions. They tell you the frequency, the voltage, and the setup. You might have more resistors. There might be a little bit more of a mess here, but this is basically the basics, and with this you can work on the future and just add whatever they ask you. So this should get you started on this. Those are the basics. You should be ready. There are other implications to using these, and it's not so straightforward as putting one end here and one end here and you got it. Sometimes you need to do a little bit different stuff, but you will learn that in the course. So good luck, and this is the end of the super tutorial.